Hi. We've been talking about the basics of Python, and today I welcome you to this session where we would actually be discussing what is the process that we should follow when we are doing projects. So the framework, which you must have seen in my earlier videos also, is called DCOVA I framework, and my first book was also on the basis of this framework, how to use it for doing projects. The first part of this framework, the D stands for define. Every element of this project, that is the data collected, the model chosen, successful metrics, this all starts with this define stage because we have to identify the business problem and then convert it into a mathematics problem, right? So this is something that we have to understand. Before we go there, let's talk about the types of data. When we were looking at the project and the way we will do it, we need to understand that every data project does need a framework because otherwise we have scattered steps, costly mistakes. And the one language, the one checklist, as I mentioned to you, is the DCOVA I checklist because it allows us to understand clearly where we are in a project. Because twice, business will ask you two types of questions. Twice you will use this framework. So the first question they will ask you is how much time will you take? And then the question they ask you is why will you take so much time? So it's very important to explain to them that there is actually a process and every part of the process for us to go through it does take some time. It's not like a black box. You come, you give us the data, the problem, and then say that give it to me by tomorrow. Okay. And then when we are at the end creating the presentation and the storytelling, we should be able to use the processes that are mentioned here, the 6 steps to be able to tell a compelling story. The types of data that we have, if you would know, is of course that 90% of the data used in business is structured data, that is rows and columns, right, with fixed schema, and every field has a defined data type. And most of this data is available in the ERP systems that support the business, CRM system, HRMS system, all of that data is structured. The second is unstructured data, which has no predefined schema and cannot be stored. This in volume could be pretty large, but the thought is that majority of the business decisions are not made on this. It is used only predominantly once it is structured. Then, of course, you have semi-structured data because finally, most of the things which you think are extremely unstructured are not. There is always a date time stamp. There will always be an origination system or person. So there are some structures already built into place. Time series data has become extremely important. So the data around sensors, and different types of machines creating data are all time series where the date time is the primary key for that type of data. Okay. Structured tables, as we all know, are very simple. There's a primary key, and then you have all the other variables of the data. Most of us have seen enough of such structured data. There is one thing that you have to check in your structured data, which is that do you have labeled data or do you have unlabeled data? So what is labeled data, you might ask? Labeled data is where you have a clear tagging that this is a fraud or this is not a fraud, this person, this customer is a good customer for me or a profitable customer or not a profitable customer, etc., right? So in this concept, this tagging, this labeling actually helps us define that can we use supervised learning algorithms or do we have to use unsupervised learning algorithms? So what do you really mean? You might say that, Subhashni, what do you mean by the supervised learning algorithm and unsupervised learning algorithm? Supervised learning algorithms are where you have a particular, really, clean Y variable where you can define the Y variable and then you can actually run certain particular um, techniques on that Y variable. For example, if you were to look at some continuous Y variable like customer lifetime value, you can use the supervised learning technique like linear regression or ridge and lasso, etc. Binary data like churn, did the customer leave? Yes, no. Did the employee leave? Yes, no. Supervised learning, you can use logistic regression, random forest, XGBoost, etc. So it is much easier. Time series, weekly ad spend efficiency, supervised learning, you can use ARIMA and the like, right? But unsupervised learning actually is predominantly customer segmentation or for targeted campaigns, etc., where the customers are not tagged as they are good customers or bad customers and the like. So all it will do is it will do clustering. Okay, it will create clusters for you saying these are similar customers. Now it is up to you to look at them more closely and decide, do you want to label them as anything, and then work on it. Okay. As I have mentioned to you earlier, all of this is available in the part one PDF file that you will find in the Google Drive. Please go ahead and in the description box, you will find the link to the Google Drive. Use it to access all the material. So this is where we were saying that we are here at the define stage. We want to understand what is the business question. We want to be able to tell what is the Y variable, is it labeled or not labeled? And then we need to be able to understand that what are the type of models, etc., that we would, that we can apply. Okay. Now, types of data we already talked about. You would meet structured data, semi-structured data, and time series data predominantly, which is that time series data is the data which predominantly comes in from all the sensors. Supervised learning, unsupervised learning, and reinforcement learning are three techniques that you can use. Supervised learning is often used with labeled data to predict and classify it, while unsupervised learning is used to for unlabeled data to find some structures and commonalities, cluster them. Reinforcement learning is the learning that we have in gamification, which is learning by reward, trial and error. So pricing bots and routing looks at reinforcement learning. The next part of what we will do whenever we have a project after defining the project is to look at what the data that we have and what we need to get from different systems. So if we were to look at it, of course, in structured data, which we know is 90% of the business data, you have the primary key, which is a unique identifier like your customer ID or your bank account ID, etc. And the primary way to create a larger data set is to either append the data one below the other or to join it or merge it, as we say. Both of these, when we are looking at Python also, and if you're somebody who's already working on SQL, please know that you can transfer those skills into Python. Okay. So this is exactly what you end up doing in collecting the data. You understand that there are some primary keys. You will work on SQL joins, and there can be sometimes, if there is no primary key, you will end up making a composite key. Sorry. SQL join types, we already understand that there are different types of joins. And if you know SQL, you will be able to transfer all the knowledge of your SQL into Python very, very easily. There are libraries in Python which allow you to code in SQL. You end up appending the data, or you can end up merging the data. Sometimes you also end up creating some synthetic data which is privacy safe. That means that you generate data that mimics the real patterns but is not actual data for every customer, especially in things like banking. This has become a very common technique that they use. Then you can have class balancing. Sometimes before you make a model, you might end up having to create samples which have maybe data from all strata. You might need to create equal good and bad data, etc., which is going to be this call is taken on the basis of which type of model you will end up using. So this is also something that you want to look at. Now let's look at organizing the data. When you look at organizing the data, there are four main things you end up doing. You do missing values, outliers, and then you can have to create some dummy variables and derived variables. So missing values is self-explanatory. in case there is anything which is missing, and then how do we actually fill up the missing values? Can we fill it up? Is there too much missing? So generally, like if 80% of the data is missing, it is better to drop that field rather than fill it up. Then, of course, you have outliers. These are unusual values. They will severely compromise the model efficiency. So, if there are outliers, sometimes you want to remove them from this data set and create separate models for them. Dummy variables, which are, you really cannot do maths on non-numeric variables. So, this is the way to create 0 and 1, that is present or not present flags for other variables like location. So if it's Agra, yes or no, Delhi, yes or no. Then you have derived variables like profit is derived from revenue minus cost, or age is derived from today's date minus date of birth. These are values which all of these increase the information value of your data set. Okay. We must also understand that this is at the organized stage, we end up trying to create or split the data set so that we can do the modeling. So that means we would end up splitting certain amount to train the model, certain amount of the data to validate it, and then to test the accuracy on the whole set of data. Okay. So definitely there is this process also, which we will do as a part of organizing the data. Okay. As I've mentioned to you, the PDF is in the drive, and I do hope you will use it. It has far more, it has far more details. If you need any help at any point, do, reach out to me. Like in outlier detection, I think you all understand that we use either the interquartile rule or we use the Z-score, which is based on normal distribution. These are the two most commonly used, formulas for it. So go ahead, and when you look at sampling strategies, you have simple random sample, then you have stratified samples and systematic sampling, etc. So all of these are available very easily for you to use from the PDF. So please do look it up. If you need any help, you can reach me. You can write a comment and I will surely respond to you, or you can reach me, contact me directly, especially over LinkedIn. Then we come to the next part, which is visualization. We all understand visualization is creating graphs and charts, and there are very common ones like box plot, bar plots, line charts, which all of us work on. But when you're working on statistics, actually, you end up working on some other ones also, like especially histograms, which tell you the distribution, scatter plots, which tell you relationship, heat maps, which can tell you correlation, etc. It can help you depict all of this. Okay. So this phase, up till this phase, this whole thing is called exploratory data analysis, so that we are making sense of the data. We are creating the data on which final models would be run. Yes. So visualization is some of the problems that we get are visualization problems. Then this is where we stop, in the sense that we end up creating graphs, charts, dashboards, and we may not go forward. Okay. And I think all of us do understand what are the different types of commonly used graphs, like bar graphs, and this is a scatter plot. Okay. This is something which is helping you understand visually what is the net promoter score, and this is a heat map which tells you what is the correlation between variables, right? This is a line graph which tells you what is the trend that is being followed. And the EDA checklist, the exploratory data analysis checklist, it tells you what is the shape of the data, what is the distribution, if there are some relationships and anomalies like outliers in the data. After this, you are in a position to look at the analyze phase. This is where we actually build the models. This is where statistics is going to be used in a very big way. Even if we are just doing a visualization, we can build some models, like we can do descriptive statistics like mean, median, mode, etc., which tell us that this month's data, is it better or worse than earlier data? Is it in range or not? Then the next big thing, which is you will notice that we end up using, is probability and confidence intervals. That is something which we will find extremely important. Hypothesis testing. All of these become extremely important especially when we are dealing with samples. And even when we are trying to figure out if this model actually works or not. Like, having this model, is it better than having no model? Of course, you have correlations, so Pearson, Spearman, chi-square. A lot of these you will find to find out relationships between the variables, because see, in business the data is really large. So one of the big things to do is to reduce the dimensions or size of data by leaving out some of the columns which are not really influencing the y variable. The common techniques over here are principal component analysis and factor analysis. After that, you move to actually the predictive analytics. So you could be doing regression, linear regression, logistic regression. You could be doing time series, or you could need to do clustering, k-means, hierarchical, Gaussian mixture. So there are many such techniques. And in Python, the best part is there are packages for all of it. So we really don't need to worry. We can go forward and look them up. So here is a summary of it. We can start off with descriptive statistics. You can move to hypothesis testing and probability. Of course, you need to understand correlation, multicollinearity, and variable selection and dimension reduction. Then you move into predictive analytics like regression, time series, and clustering, which is not really predictive, but it is more to do with segregation, right? At the end of it, we have to answer some questions, right? Which of the models are really good, and which is the model that we should implement for this problem, solution of this problem? So how do we compare models become really important. So you have the confusion matrix, which is the type 1, type 2 errors. Then you have the area under the curve. You have the Gini coefficient. All of these are methodologies which are used to compare models and then give a understanding that this is the right model that we want to proceed with for the solution. Okay. So these are some examples that will help you understand all of what we spoke about. The confusion matrix, which tell us the true positives and the true negatives. The ROC curve, which tells us that which is the better model, whichever has maximum area under the curve is the better model. Then, of course, like this is a comparison of what is the area under the curve, choosing the right threshold of 4 different models, and then, how will we monitor and redevelop this model? When do you think that we will monitor and redevelop this model? This actually is a decision which is an ongoing decision often. So we end up making a dashboard which actually um, monitors the model every quarter or 6 months so that we can take a call that, do we need to redevelop the model? So again, just to tell you that the whole full loop is something that we will follow for all our projects. However, sometimes we may have steps that really don't make any sense for a project, and we will not have to do those steps. Okay, we can skip it. Like, if all the data is already collected together, if all the data is already organized well, then maybe we don't need to do these steps. Okay. What I would love you to do is to, let me just switch on my camera. What I would love you to do is to pick a business question, run it through all the 6 stages, at least as a theory and theoretical exercise, and just get a feel that how would a project really work. I'd look forward to your comments, and I do hope you will like and subscribe to the channel.